Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and we're continuing our journey through the fascinating world of concurrent collections in Java. Today, we're diving into ConcurrentSkipListSet, an intriguing member of the java.util.concurrent package. Victor, are you ready to unravel this mystery for our listeners?
Absolutely, Sheila. I'm excited to explore ConcurrentSkipListSet with you and our audience. It's a powerful tool in Java's concurrent collection arsenal, and understanding it can really level up one's concurrent programming skills.
Great! Before we jump in, let's set the stage for our listeners. We're currently in the concurrent collections season, specifically in the Maps and Sets chapter. We've already covered concurrent map, concurrent hash map, and concurrent skip list map. Today's topic, concurrent skip list set, builds on that knowledge. Listeners, if you haven't caught those episodes yet, I highly recommend giving them a listen for context. Now, let's kick things off with a quiz question to get our brains warmed up. Here's the question. In a skip list data structure, what's the average time complexity for search, insertion, and deletion operations? Is it O log n, O n, or O1?
That's an excellent question, Sheila. It really gets to the heart of why skip lists are so interesting. Without giving away the answer, I'll say that this time complexity is crucial to understanding the performance characteristics of concurrent skip list set. Listeners, think about how the structure of a skip list might affect these operations. Is it more like a linked list, an array, or something in between?
Great points, Victor. While our listeners ponder that question, let's start with the basics. Can you give us an overview of what concurrent skip list set is and why it exists in the Java Concurrent Collections framework?
Certainly. Concurrent skip list set is a concurrent sorted set implementation based on a skip list data structure. It provides a thread-safe, scalable alternative to synchronized sorted sets. The key feature of concurrent skip list set is that it allows multiple threads to perform read and write operations concurrently without blocking each other, which is crucial for high-performance, multi-threaded applications.
That sounds powerful. So it's thread-safe and allows concurrent access. But I'm curious, what exactly is a skip list? It sounds like some kind of data structure that lets you skip over elements, but I'm not sure how that works.
Great question, Sheila. A skip list is indeed a clever data structure. Imagine you're in a skyscraper with 100 floors and you want to get to the 75th floor. Instead of stopping at every floor, you might take an express elevator that stops every 10 floors, then switch to a local elevator for the last few floors. That's essentially how a skip list works. It creates express lanes in the data structure to speed up searches.
Oh, that's a fantastic analogy. So in terms of the actual implementation, how does this translate to the data structure?
In a skip list, elements are arranged in layers. The bottom layer contains all elements in sorted order, like a linked list. Each higher layer acts like an express lane, containing fewer elements but allowing for faster traversal. When searching, you start at the top layer and work your way down, skipping large portions of the list. This is what gives skip lists their efficient search, insertion, and deletion operations.
I see. That's really clever. So, how does this compare to other concurrent collections we've discussed, like concurrent hash map or concurrent skip list map?
Great question for comparison. Unlike concurrent hash map, which is unordered, concurrent skip list set maintains its elements in sorted order. It's more similar to concurrent skip list map in its internal structure, but it's a set, so it doesn't store key value pairs, just unique elements. The set in its name means that it doesn't allow duplicate elements.
That makes sense. Now, you mentioned it's thread-safe and allows concurrent access. Can you elaborate on how it achieves this without compromising performance?
Absolutely. Concurrent skip list set uses lock-free algorithms for its operations. This means that instead of using traditional locks, which can cause contention and blocking, it uses atomic operations and clever algorithms to ensure thread safety. Multiple threads can perform reads and even writes concurrently, without blocking each other. This leads to excellent scalability, especially in multi-core systems with high concurrency.
That's impressive. It sounds like it could be really useful in certain scenarios. Can you give us an example of where concurrent skip list set might be the ideal choice in a real-world application?
Certainly. Imagine you're building a high-frequency trading system where you need to maintain a sorted list of stock prices that's constantly being updated and read by multiple threads. Concurrent skip list set would be perfect for this. It allows concurrent updates as prices change, maintains the prices in sorted order, and provides fast access for threads that need to read the current prices.
That's a great example, Victor. Now, I'm curious about the performance characteristics. Are there any trade-offs or situations where concurrent skip list set might not be the best choice?
Excellent question, Sheila. While concurrent skip list set offers great scalability and concurrent performance, it does have some trade-offs. The skip list structure means that it uses more memory than a simple list or tree. Also, for very small sets or in single-threaded scenarios, simpler data structures might perform better. It's really optimized for concurrent, multi-threaded environments with a moderate to large number of elements.
I see. So it's not a one-size-fits-all solution. Are there any common pitfalls or misunderstandings that developers should be aware of when using concurrent skip list set?
Absolutely, Sheila. One common misunderstanding is assuming that because it's concurrent, it's automatically faster in all scenarios. As I mentioned, for small sets or single-threaded use, simpler structures might be more efficient. Another pitfall is relying on the size method for accurate real-time size. Because of its concurrent nature, the size can change even as the method executes, so it's only an estimate.
Those are great points, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. The question was, in a skip list data structure, what's the average time complexity for search, insertion, and deletion operations? Victor, would you like to do the honors?
Of course. The answer is O log n. This logarithmic time complexity is what makes skip lists, and by extension concurrent skip list set, so efficient for large datasets. It's comparable to balanced tree structures, but with the added benefit of lock-free concurrency.
Thank you, Victor. To summarize today's episode, 1. Concurrent skip list set is a thread-safe, sorted set implementation based on skip lists. 2. It allows for concurrent read and write operations without blocking. 3. It's ideal for scenarios requiring a sorted concurrent set with frequent updates and accesses. 4. It offers O log n, time complexity for its main operations. 5. While powerful, it's not always the best choice for small sets or single-threaded scenarios. In our next episode, we'll be exploring copy-on-write collections, another fascinating topic in concurrent programming. Don't miss it. If you've enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue bringing you in-depth explorations of Java's internals. Until next time, happy coding.